The James Webb Space Telescope is revealing something that should not exist. Fully formed galaxies, already massive and structured, appeared just a few 100 million years after the Big Bang. According to standard cosmology, the early universe should be simple, chaotic, and slowly building itself over billions of years. But JWST is showing something completely different. Bright, complex galaxies are already in place. Far too early, far too advanced, and far too organized to fit the timeline we've always believed. And with every new image, the contradiction grows stronger. Chapter 1. The telescope that broke cosmic timelines. At 13.5 billion light-years distance, the James Webb Space Telescope has identified fully formed galactic structures. According to the Lambda-CDM model, the institutional standard for cosmic evolution, these objects should not exist for another 500 million years. NASA is currently holding a dataset that breaks its own timeline. Instead of faint primitive structures, JWST detected galaxies already bright, organized, and fully formed only a few 100 million years into cosmic history. These were not early fragments of matter. These were massive, structured systems with mature star populations and defined shapes. According to accepted models, the universe at that time should still be forming small, irregular clumps, not fully developed galaxies. Each new observation strengthens the same pattern. The early universe is not evolving slowly. It appears fully active from the very beginning. It is a direct challenge to the timeline that defines the origin of everything. And that challenge continues to intensify with every new dataset released. Chapter 2. The galaxies that should not exist this early. As JWST continues scanning deeper into space, astronomers are identifying galaxies at extreme distances that correspond to the earliest periods of cosmic history. These galaxies are not small or underdeveloped. They are massive, structured, and fully formed. This creates a direct conflict with established cosmological timelines. It should still be in a phase of slow matter accumulation, where small structures gradually merge into larger ones over long periods of time. What is emerging is a revised view of the early universe as an environment capable of producing complex structures far earlier than previously believed. Chapter 3. The Little Red Dot Phenomenon. Among the most disturbing JWST discoveries are compact, extremely bright objects now classified as little red dots. These sources appear small in physical size but emit extraordinary levels of energy from deep within the early universe. Their red coloration suggests extreme absorption of light by surrounding material, indicating intense internal processes. The dominant interpretation emerging from astrophysical analysis is that these objects are powered by rapidly growing supermassive black holes surrounded by dense gas and dust. These are extreme energy systems, where black holes dominate the environment. Instead of being secondary features inside galaxies, black holes appear to be central engines shaping structure from the beginning. The little red dots are the evidence. They are active, supermassive black holes operating at a scale that contradicts standard stellar evolution. The early universe was not shaped by star formation. It was engineered by supermassive black holes. The deeper questions are not unanswered. They are simply suppressed by those who refuse to rewrite the institutional textbooks. Chapter 4. The Collapse of the Slow Universe Model. For decades, the dominant model of cosmic evolution followed a slow, linear progression. Matter cooled after the Big Bang. Stars formed gradually. Galaxies assembled over billions of years. JWST data show early cosmic environments that are far more efficient and active than previously modeled. Star formation rates appear accelerated. Gas collapse appears rapid. Galaxy assembly appears far faster than theoretical timelines allow. The early universe was not a quiet expansion of simple matter. It was a high-energy environment where gravity, gas density, and radiation interacted at extreme levels, producing structures faster than expected. Every new JWST observation adds weight to this revision, and each revision moves the scientific community further away from the original slow-growth model. Chapter 5. Black holes before their time. One of the most disruptive findings from JWST involves supermassive black holes existing extremely early in cosmic history. Traditional theory assumes black holes grow gradually over long periods through steady matter accumulation. But JWST observations show black holes that are already massive and highly active in the early universe. This forces a different interpretation of black hole growth. Instead of slow accumulation, early black holes may have experienced rapid feeding phases where they consumed enormous amounts of gas in short periods of time. These extreme growth events would explain both their size and their brightness in early cosmic environments. More importantly, it suggests black holes were not late additions to galaxy formation. They were present at the beginning, actively influencing how matter collapsed and how galaxies formed. This shifts their role from end-stage objects to primary drivers of cosmic structure. The early universe may have been shaped more by black holes than by stars. Chapter 6. NASA, Data Transparency and Controlled Interpretation. NASA claims all JWST data is publicly released. While the raw telemetry is accessible, the institutional interpretation is not. NASA administrators are currently enforcing a rigid framework that prevents scientists from discussing these galaxies as anything other than anomalies. The interpretation of JWST findings is not under debate. It is under a managed containment policy. Different research teams analyze identical observations and arrive at conflicting conclusions. Some classify early objects as rapidly formed galaxies. Others interpret them as black hole-dominated systems. NASA's official position emphasizes caution, peer review, and verification before conclusions are accepted. There are growing claims suggesting that the interpretation of JWST findings is tightly managed within institutional frameworks, slowing the acceptance of disruptive conclusions. While the data itself is not concealed, the full implications of that data are still under intense debate and review. If you are following this series on deep space discoveries, early universe anomalies, and JWST breakthroughs, subscribe now. Chapter 7. The universe is rewriting its own beginning. The universe is no longer appearing as a slow, predictable expansion from simplicity to complexity. Instead, it is showing signs of rapid structure formation, early black hole dominance, and galaxies that appear fully formed far earlier than expected. The early universe is not behaving like a gradual system. It is behaving like an environment that reached complexity almost immediately after formation. If galaxies existed so early in such advanced forms, what conditions created that level of structure so quickly? The universe is not finished revealing its earliest structure. It is actively changing how we define its beginning. And what JWST has shown so far may only be the first layer of a far deeper cosmic history that has not yet been fully exposed.